The video begins with a breathtaking view of the night sky, showcasing the Milky Way stretching like a luminous band across the vastness of space. The camera slowly pans across this celestial scene, immersing the viewer in the scale and beauty of the cosmos. As this majestic view unfolds, the voiceover begins. For centuries, the vastness of the cosmos has captivated human imagination. We gaze up at the stars and wonder about our place in this grand cosmic tapestry. And at the heart of this wonder is our very own galactic home, the Milky Way. As the camera zooms in on the bright core of the galaxy, the voiceover transitions. But what exactly is the Milky Way? Is it merely a band of light in the night sky, a collection of distant stars, or something far more profound? This moment of curiosity is designed to hook the viewer's attention by presenting a simple question with immense cosmic implications. It invites the audience to think about the galaxy in ways they may not have considered before. To solidify engagement, the narrator continues, "Join us on this journey, and by the end of it, you'll see the Milky Way not just as a distant spectacle, but as a living, breathing structure that holds the answers to some of the universe's greatest mysteries, and perhaps even the key to understanding our own existence." This promise of revelation sparks the viewer's curiosity, ensuring they stay invested in learning more about the wonders of the Milky Way throughout the video. By opening with awe-inspiring visuals and a thought-provoking question, this introduction sets the stage for an engaging exploration of one of the universe's most fascinating structures, building anticipation for what's to come. The Milky Way is not just a random scattering of stars, it's a vast barred spiral galaxy, one of the most common types in the universe. Imagine a cosmic pinwheel with long, curving arms that spiral outward from a central bar of densely packed stars and gas. The entire structure spans a staggering 100,000 light-years in diameter. To put that into perspective, if you were to travel at the speed of light, it would take you 100,000 years to cross from one side of the Milky Way to the other. This immense scale is beyond what most of us can easily comprehend. Yet we are just a tiny part of this vast system, tucked away in one of its spiral arms, known as the Orion Arm. To help grasp the sheer enormity of the Milky Way, let's use a more familiar analogy. If our entire solar system, everything from the Sun to Pluto, were the size of a single grain of sand, the entire Milky Way would be the size of a beach. That's right. Our whole solar neighborhood would be just one speck on an expansive coastline of stars, planets, and cosmic dust. This analogy gives us a humbling sense of scale and reminds us how small we truly are in the grand scheme of the universe. Even though we may think of the solar system as large, it's just a tiny fraction of our galaxy's mass. But the real marvel lies in the staggering number of stars that populate the Milky Way. Scientists estimate there are around 200 billion stars within our galaxy, each one potentially hosting planets, moons, and perhaps even life. Among these stars, our Sun is just one ordinary star, not particularly large or bright compared to the others. But what's even more fascinating is that this number, 200 billion, isn't static. The galaxy is constantly in flux, with new stars being born from clouds of gas and dust in stellar nurseries, while older stars reach the end of their lives in spectacular supernova explosions. And while we have identified 200 billion stars, some estimates suggest that the Milky Way could harbor even more, potentially hiding planets and cosmic phenomena we have yet to discover. One of the most incredible facts about our solar system is that it is not stationary. Rather, it's constantly moving through space, orbiting the center of the Milky Way galaxy. This journey, often referred to as a cosmic year, takes approximately 225 to 250 million years to complete a single rotation. To put that into perspective, the last time our solar system was in its current position within the galaxy, dinosaurs still roamed the Earth. Since then, entire species have risen and fallen, and our planet has undergone drastic changes. The length of this cosmic year is a testament to the immense scale of the Milky Way and the slow but steady movement of celestial objects within it. As our solar system orbits the galactic center, it follows a slightly elliptical path, much like the orbits of planets around the Sun. This orbital motion is driven by the immense gravitational forces exerted by the Milky Way's mass, which includes not only stars and gas, but also a significant amount of dark matter. What's even more fascinating is that our solar system is moving at an incredible speed of approximately 828,000 kilometers per hour, 514,000 miles per hour. Despite this immense speed, the vast distances in space make this motion imperceptible to us on a daily basis. The motion of the solar system is governed by the gravitational forces within the galaxy. At the center of the Milky Way lies Sagittarius A, a supermassive black hole that exerts a strong gravitational pull on everything around it. However, the solar system is far enough from the galactic center, about 27,000 light-years, that it is primarily influenced by the collective gravitational forces of the stars, gas, and dark matter in the galaxy rather than the direct pull of the black hole. The gravitational balance in the Milky Way is a complex dance of forces. As our solar system orbits the galactic center, it is also subject to the influence of other nearby stars and cosmic objects. This creates subtle shifts in our trajectory over time, leading to oscillations above and below the galactic plane in what scientists call galactic bobs. Additionally, the solar system experiences tidal forces as it moves through areas of the galaxy with varying mass densities. These forces can affect the orbits of comets and asteroids in the distant reaches of our solar system, potentially even sending some hurtling toward the inner planets, including Earth. But the most awe-inspiring part of this galactic journey is the fact that our solar system is not alone. Every star, every planet, and every stellar system in the Milky Way is undergoing a similar rotation around the galactic center. Together, we form a vast rotating disk of matter that moves in harmony, driven by the fundamental force of gravity. This dynamic structure is a testament to the power of gravitational interactions on a cosmic scale, showing us how everything in the universe is interconnected through these invisible yet all-encompassing forces. By understanding the orbit of our solar system and the galactic forces at play, we gain deeper insights into how the universe works, how our galaxy functions, and ultimately, how we are all part of something much larger than ourselves. Like DGA Sobrikuri Shafarikuri doesn't say for why Simenyeseri. These stars are packed so tightly together that in some areas the night sky would appear much brighter than what we see from Earth. If you were near the center of the bulge, the sky would be ablaze with starlight. The galactic bulge also contains an unusually high concentration of globular clusters, tightly bound groups of stars that are among the oldest in the galaxy. These ancient stars serve as a kind of fossil record for astronomers, offering clues about the early stages of the Milky Way's formation. The gas and dust in this region also play a key role in star formation. While most of the stars in the bulge are old, new stars are still being born in some of the dense clouds of gas that surround the galactic center. The interplay between the supermassive black hole and the galactic bulge creates a dynamic environment at the core of the Milky Way. This region is a place of intense gravitational forces, rapid stellar movement, and ongoing star formation, an area that defines the structure and behavior of our galaxy as a whole. It is a reminder that even in the seemingly tranquil depths of space, there is constant activity and energy shaping the cosmos. The Milky Way is a barred spiral galaxy, meaning it has long, sweeping spiral arms that extend from its central region, curving outward like a grand celestial pinwheel. These spiral arms are where some of the most dynamic and fascinating processes in the galaxy occur, particularly the birth of new stars. Within these arms, vast clouds of gas and dust, often referred to as stellar nurseries, provide the raw material for star formation. These regions are dense with hydrogen, the most abundant element in the universe. And, under the right conditions, gravitational forces cause these gas clouds to collapse in on themselves, igniting nuclear fusion in the core of the collapsing cloud and giving birth to a new star. This process is particularly active in the spiral arms because these regions are subject to compression waves, also known as density waves. These waves move through the galaxy, compressing gas and dust and triggering star formation as they pass. The stars born in the spiral arms are typically hot, young, and massive, shining brightly in ultraviolet light, which illuminates the surrounding gas and creates the bright, glowing regions we observe in galaxies like our own. The Orion Arm, where our solar system resides, is one of these active regions, and it contains numerous star-forming regions, such as the famous Orion Nebula. In addition to individual stars, the spiral arms also host the formation of star clusters, groups of stars that form together from the same cloud of gas. Over time, these clusters may disperse, but some remain gravitationally bound, traveling together through the galaxy. The spiral arms are therefore not just beautiful structures, but are the lifeblood of the galaxy, continuously recycling gas and dust into new generations of stars and planetary systems. Though the Milky Way seems relatively stable now, its future is marked by an event of colossal proportions. In about 4.5 billion years, the Milky Way is on a collision course with its neighboring galaxy, Andromeda. This isn't something to fear. Galactic collisions are relatively common in the universe, and they unfold over such long timescales that they pose no immediate threat to planetary systems like our own. When galaxies collide, it's not the stars themselves that are crashing into each other. Instead, it's more like two massive clouds of stars passing through one another. However, the gravitational interactions during this collision will dramatically reshape both galaxies. When the Milky Way and Andromeda merge, the resulting structure will likely be a giant elliptical galaxy. This process will take millions of years and will lead to an intense period of star formation as gas clouds collide and compress, creating new stellar nurseries. The stars within both galaxies will be flung into new orbits, and some systems may even be ejected from the galaxy altogether. Our own solar system may be sent into a new, more distant orbit, or it might even be expelled from the merged galaxy entirely, sent drifting through intergalactic space. The collision between the Milky Way and Andromeda is a reminder that the universe is constantly evolving, and that even on the scale of galaxies, change is inevitable. While we won't be around to witness this cosmic event, its consequences will shape the structure of the local universe for billions of years to come, marking the end of one era and the beginning of another in the history of our galaxy. If you're enjoying this cosmic journey so far, don't forget to give this video a thumbs up. It helps more people discover these astronomical wonders, and it allows us to keep exploring the universe together. Neil deGrasse Tyson. The Milky Way is not only our galactic home, but it's also a living laboratory where stars are born and die. One of the most prominent voices in popular astronomy frequently describes the Milky Way as a dynamic system, a living laboratory where the life cycles of stars unfold before our eyes. This poetic description captures the essence of what makes the Milky Way so fascinating. It's not a static entity, it's constantly evolving. Stars are born in vast stellar nurseries within the spiral arms, only to die in dramatic supernova explosions that pave the way for new generations of stars. Tyson emphasizes that by studying the processes within our galaxy, we gain invaluable insight into the fundamental mechanics of the universe itself. The Milky Way offers an exceptional vantage point for astronomers, as it showcases the entire life cycle of stars, from their formation in clouds of gas and dust to their eventual demise, either as white dwarfs, neutron stars, or black holes. Tyson's perspective reinforces the idea that the Milky Way is not just a collection of stars, but a complex, ever-changing system where energy is continuously recycled. This process allows us to observe the birth of new elements, the fusion of hydrogen into helium in stellar cores, and the creation of heavier elements like carbon and oxygen, essential ingredients for life as we know it. The study of the Milky Way not only helps us understand our own galaxy, but also serves as a key to unlocking the secrets of other spiral galaxies in the universe. Spiral galaxies like the Milky Way are some of the most common structures in the cosmos, and they share many characteristics. By examining the intricate details of our galaxy, we can make broader assumptions about how other galaxies behave, especially regarding star formation, stellar populations, and galactic dynamics. For example, by observing how stars move within the Milky Way's spiral arms, and how its central bulge influences galactic rotation, astronomers can infer similar processes occurring in distant galaxies. This comparison allows scientists to refine models of galaxy formation and evolution, helping to answer fundamental questions about how galaxies grow, merge, and change over time. In essence, the Milky Way serves as a template, a nearby example that we can study in detail to understand the broader patterns of the universe. This comparative analysis has led to discoveries about how galaxies interact, how dark matter influences their structure, and how they evolve over billions of years. One of the greatest mysteries of modern astrophysics is the role of dark matter in the universe, and the Milky Way is central to this enigma. Dark matter is an invisible form of matter that does not emit, absorb, or reflect light, making it impossible to detect directly. However, its presence is inferred from the gravitational effects it exerts on visible matter. such as stars and gas. In fact, dark matter is believed to make up about 85% of the total mass of the universe, and our galaxy is no exception. The rotation of the Milky Way provides crucial evidence for the existence of dark matter. According to Newtonian physics, the stars at the outer edges of the galaxy should orbit more slowly than those closer to the center. However, observations show that stars far from the galactic core are moving much faster than expected. This discrepancy can only be explained if there is an enormous amount of unseen mass, dark matter, encompassing the galaxy and exerting a gravitational pull. The Milky Way's behavior under the influence of dark matter helps scientists develop models that explain the structure of galaxies on a universal scale. Understanding dark matter's role in the Milky Way has far-reaching implications for the study of the universe's overall composition, including how galaxies form, cluster, and evolve. While we may not yet fully understand what dark matter is, the Milky Way serves as a natural laboratory for exploring this invisible yet incredibly powerful force. By studying dark matter in our galaxy, we move closer to solving one of the greatest cosmic mysteries of all time: what makes up the majority of the universe's mass. This knowledge could revolutionize our understanding of the universe's underlying framework, from the smallest galaxies to the largest galactic clusters and everything in between. The Milky Way is more than just our home in the universe. It's a colossal dynamic system filled with billions of stars, countless planets, and endless possibilities for life. It stretches across 100,000 light years, containing both the known and the unknown, from familiar objects like our sun and neighboring stars to mysterious phenomena like black holes and dark matter. Our journey through the galaxy reveals that the Milky Way is constantly evolving, with stars being born in stellar nurseries, planets forming in proto-planetary disks, and ancient stars reaching the end of their lifespans in supernova. These processes, happening right within our galactic home, help us understand the fundamental mechanics of the universe itself. Every time we look deeper into the Milky Way, we uncover more about the cosmic forces that shape not only our galaxy, but also others across the universe. And remember, this is just one galaxy out of potentially trillions. The Milky Way, vast and majestic as it is only a small piece of the grand cosmic puzzle. Imagine what else is out there in the depths of space: entire galaxies teeming with stars, planets, and mysteries waiting to be discovered. What lies beyond the Milky Way? Could there be other galaxies with planets harboring life, or perhaps even more exotic phenomena that we have yet to encounter? The more we learn, the more we realize how much we still don't know, and that's what makes the universe so endlessly fascinating. This call to reflection serves to remind viewers of the vastness and mystery of the universe. It ties everything back to the core theme of wonder and curiosity, leaving the audience pondering the endless possibilities that lie beyond what we currently understand. The message encourages continued exploration and a sense of awe, not just about the Milky Way, but about the universe as a whole. If you're as fascinated by the cosmos as we are, make sure to subscribe to the channel and hit the notification bell for more space explorations. We'll be diving into everything from distant galaxies and black holes to the search for extraterrestrial life in future videos. Don't miss out on the adventure, there's so much more to discover. This call to action is not just a push for subscriptions, but an invitation to join an ongoing journey of cosmic discovery. By framing the subscription as a way to be part of an exploration, the CTA taps into the audience's sense of curiosity and wonder, making them feel like active participants in a shared quest for knowledge. What aspect of the Milky Way blew your mind the most? Was it the sheer size of the galaxy, the incredible speed at which the solar system travels, or perhaps the existence of a supermassive black hole at its center? Share your thoughts in the comments. We'd love to hear what fascinates you most about our galactic home. This interactive CTA is designed to foster community engagement by encouraging viewers to share their thoughts and insights. It invites the audience to reflect on what resonated most with them, creating a space for discussion and further curiosity. By prompting specific questions related to the video content, it increases the likelihood of meaningful comments, which in turn helps build a stronger connection between the audience and the channel.